Here we go, Samir. It's your favourite song in the whole wide world.
It's time for Maths with Mr. Thomas.
Oh yeah! Here we are with Chapter 7, Lesson number 6. This is the second lesson that we're looking at the sine rule. If you remember in the last lesson we were using the sine rule to work out the length of a side, and we're moving on now to look at the size of an angle. Notice though, all of the angles are going to be less than 90 when it comes to angles that are bigger than 90 degrees, between 90 and 180. They're all in the next lesson with ambiguous cases. So we're using the sine rule to work out the size of an angle, but all of them are less than 90. So, let's try that. You will remember that we can't use SOHCAHTOA to work out the size of angles or sides in non-right angled triangles. So instead, one of our options is to use the sine rule. And this is our sine rule here, just from the last lesson. We have A over sine A equals B over sine B equals C over sine C. And the main thing that we need to use when we're looking for the sine rules, help me out Adam, is look for pairs. Good, we've got to look for pairs. And what do we mean by pairs? That's when you've got an angle in the side across from it. Perfect Adam, yes, you are perfectly right. Good. In this formula here, we've got capital letters and we've got lowercase letters. Joe, help us out. Good. The lowercase letters represent sides. So here the sides are going to be at the top. They're the lowercase letters. And the capital letters. What are the capital letters, Chris? Yeah, the capital letters represent angles. So we've got the side over sine of the angle equals, again, another side over sine of the angle equals another side over sine of the angle. That is what we were looking at in the last lesson. However, in the last lesson we were looking at sides. If we're wanting to work out the size of an angle, what we do with this formula is we flip it upside down. So we end up with, instead of A over sine A equals B over sine C equals C over sine C, we get sine A over A equals sine B over B equals sine C over C. And the same thing again, the lowercase letters represent the sides and the capital letters represent the angles. So it's sine of the angle, again sine of the angle, sine of the angle. And again, when you're using sine rule, you need to be looking for pairs. Shall we try some examples with that? Oh yes, please! Let's go then. So, calculate the size of the angle marked X in this greyish blue triangle. So this angle is X, this angle is 58, this length is 75 meters, and this length is 66 meters. Folks, it is the same as what we did before. We are wanting to start with what we want to find. So we are wanting to work out the size of this angle. So because we're wanting to work out the size of the angle, we are starting with that. But remember, if you want to work out the size of an angle, the angle has to go on top. And remember, it's always sine of the angle. So when we're writing this, because we're wanting to work out the size of angle X, we're going to have sine X. That's what we're starting with. Notice here in the formula I'm saying that lowercase letters represent sides, capital letters represent angles, but I'm using the lowercase letter here for the angle. It's just in the formula where the lowercase letters are for the sides and the capital letters are for the angles. You may be given a lowercase letter for an angle just like this, but it's the formula here that it is referring to. So, because the capital letters represent the angles, we can see the angles are on top and it's the sine of the angle. Angle here happens to be X, so it's sine X. We're going to be dividing that by what? Well, what is that paired up with? Well, whenever we get a pair, it's going to be the angle and the side across from it. So X is going to be paired up with 75. So it'll be sine X divided by 75. That will be equal to, what is our other pair? Do we have another pair in there, Daniel? Yes, we do. And what is it, Daniel? It's the 58 degrees. Good. And the 66 meters. Good, well done. And which one's going to be in the top? Well, because we're wanting to find the angles are going to be on top. And it's always sine of the angle. So it'll be sine 58. Well done, Daniel. Yeah. So it's sine 58 divided by, and what are you dividing it by? 66, obviously. Thank you, Daniel. After that, we are wanting to get x on its own. But let's get sine x. First of all, let's find out what sine x would be. So, how do we go from sine x divided by 75 just to sine x?
Well, we cancelled out the divide by 75.
We did indeed, yeah. What we did was really multiplied that side by 75. And the divide by 75 and times by 75 would cancel out, leaving us with sine x. But because we're multiplying this side by 75, we would also multiply this side by 75 as well. And the way we write that is we tend to put 75 times sine 58, just so we're not messing that up on the calculator. So 75 times by sine 58, and when you're multiplying, it goes on the top. And we're still dividing that by 66. As I said in the last lesson, notice how this fraction is not really changing. It is still sine 58 in the top. It is still 66 in the bottom. We're just adding in that times by 75. If you work this out in the calculator, 75 times sine 58 degrees divided by 66, you end up with 0.96369 blah 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 blah. And that is what sine x is. But we don't want sine x, we want angle x. How do we get x just in its own body? What do we do? Good, well done. We would have to do sine to the minus 1 of this number. It is the inverse of sine. So, if you work out sine to the minus 1 of our previous answer, again, just keep this answer on the calculator. Just press shift sine equals, or inverse sine equals, or second sine equals. You may have to include the answer button. Check it on your calculator. If you work that out, you end up with... Good, you get 74.51 degrees. Yeah! Well done, people! Example 2. Calculate the size of the angle marked H in this lovely green triangle with the 8.3 centimetres, the 11 centimetres, the 48 degrees, and this H that we are wanting to find. So, how do we go about working out the size of angle H? Help us out, Hermione! Yeah, we want to start with what we want to find all the time whenever we're using sine rule. So because we are wanting to work out the size of angle H, we're going to start with H. But notice though, it's not just H on its own, it's always sine of our angle. Whenever it's sine rule, it's always sine of the angle. Whether it be the angle you're working out or the side you're working out, it's always sine of the angle. So it is going to be sine H, and we're dividing that by. Notice how I am putting it on the top, because if you're working out the size of the angle, you flip the formula upside down. In the exam, you're given A over sine A, B over sine B, C over sine C. But if it's the angle you want, imagine upside down with sine A over A, sine B over B, sine C over C. And in the formula, lowercase letters represent sides and capital letters represent the angles. Because it's an angle we want, we could imagine this, or capital A, capital B, capital C as angles. So it'll be sine H, and we're dividing that by its pair. What is H paired up with? The side across from it. Good, so it'll be sine H divided by 11. And that will be equal to, what is our other pair? Well, it's the 48 degrees. Yeah, and the 8.3 centimetres. Good, what's going to go on top? 48. Just 48? No, sine of 48, because it's sine of the angle. Good, so it's going to be sine 48 divided by 8.3. Well done, good. We want to work out H, but first of all get sine H. Just like that first example, we're getting rid of the divide by 11 by timesing by 11. So on the other side, we would also times by 11. And when we're multiplying by 11, we just put it on the top. So with the sine 48, we would times that by... Don't know what I'm doing there. We would multiply that by 11. But again, we tend to put it just first. So it's 11 times by the sine 48. Because we're not wanting in the calculator to work out sine of 48 times 11. That's totally wrong. It's 11 multiplied by whatever sine of 48 is. So sine 48 times by 11, and we're dividing it by 8.3. If you work that out in the calculator to work out sine H, go on. Boop, 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 boop. You get 0.98489 blah 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 blah. But we're wanting just to get H, so we would have to... We'd have to do sine to the minus 1. Good, so it's sine to minus 1 of that previous answer. And if you do that in the calculator, shift sine equals, or shift sine answer equals, whichever way you work it, hopefully you know by now, you end up with H being 80.03 degrees to a couple of decimal places. Woo! Do another example? Oh, yes, please. Example 3, calculate the size of the angle ABC. So, how do we go about doing this? Which angle is it we're wanting to find? Well, if we go from A to B to C, A to B to C, that is the angle that we're wanting. It's this angle down here at B. So, start once again with what you want to find. That's what you always do whenever it's one of the sine rule questions. So, because that's the angle you want to find, B, where B is, it's going to be sine B. And we're dividing that by, well, again, it's sine of our angle divided by the side. And that's going to be, again, a pair. So it's the angle with its pair, with the side across from it. So it'll be sine B divided by 9.3. That's going to be equal to, what will that be equal to, Joseph?
Well, we need to look for another pair.
Good, and what's another pair? The angle 56. Good, and the side 10 meters. Good, so what's going to go in the top? Well, because it's the angle's going on top, and it's always sine of the angle. Good, so it'll be sine 56. Well done, Joseph. And we're dividing it by 10. Good, well done. After that, get sine B just on its own by getting rid of the divide by 9.3. Because we're getting rid of divide by 9.3, we would multiply by 9.3, and that would cancel out the divide by 9.3 when we're timesing it by 9.3. But on the other side, we would also have to multiply this by 9.3 as well. So when we multiply, we just put it on the top, but again, put it in front of sine, so it's going to be 9.3 times sine 56. And again, we're dividing that by 10. From there, if you work that out in the calculator, we get 0.77100 and so on. But from there, Moosmill, what would you have to do?
Do sine to the minus 1.
Good, because to get B just on its own, we would do sine to the minus 1. That's the inverse sine of the 0.77100, blah, 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 blah. And if you work that out in the calculator, what do you end up getting, Craig? Yeah, well done. You get 50.44 degrees, which means then, I suppose you could leave it as that, but we're asked to work out the size of angle ABC, so I'm finishing off saying that angle ABC would therefore be the 50.44 degrees. Da, 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 da. Yeah. Is that okay? Good. Let's try another one. One last one. Here we go. Calculate the size of angle DRG. Boom, 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 boom. Go from D to R to G, and that's the angle you want. DRG, it's this angle down here. So, what do we do?
Well, because it's a sine rule question, you always want to start with what you want to find.
You do indeed, yes. So, start with what you want to find. And we're wanting this angle here, R.
But because it's a sine rule, it's always going to be sine R, or sine whatever.
You're perfectly right, yes. So it would be sine R, and we're dividing that by...
It's pair, and it's paired up with the 22 centimetres.
Good, so we're going to have sine R divided by 22. Again, with this formula here, we're putting the angle on top, and it's sine of the angle divided by the side. So it'll be sine of our angle R divided by the side. What's our other pair? Good, it's going to be the 114 and the 29 centimetres. So we would have sine of our angle, so sine of 114, divided by the side. And the side that's across from the 114 is the 29 centimetres. So sine of 114 divided by 29. Once again, just like all the other examples, get sine R on its own. So to cancel out divide by 22, we times by 22. But to keep both sides equal, you'd also times this by 22. When you multiply by 22, again, when you times, put it on top, but put it in front of sine. So it's going to be the sine 114 times 22, but write as 22 times sine 114. And we're still dividing by 29. Notice the only difference between this line and this line is the times by 22. From there, if you work that out on the calculator, you get 0.69303 and so on. But you are wanting to work out arm, Jim lad. And you'd have to do sine to the minus 1 to get that. Good, you'd have to cancel out sine. So, sine to the minus 1 of 0.69303 gives you 43.87 degrees R. That's perfectly right. Good. And because we're asked to work out the size of angle DRG, I'm just finishing it off saying that angle DRG would equal the 43.87 degrees. Yeah. Notice how, once again, none of those angles we had to work out were obtuse angles. They were all acute angles. If it's obtuse angles you're wanting, they're in the next lesson. Lesson 7.7. Have a look at some of them, but just check this makes sense for working out the size of the angle. There are some questions just in the TJ book, page 79, exercise 8.4, or use any textbook you like. Enjoy, practice this. Hopefully it made sense. Let me know. I'm curious. Bye.